Okay, let's go ahead and begin our T-notes for scientific notation. Scientific notation is a way to simplify very large or very small values, which is a really important way to communicate numbers without having to have lots of zeros either in the front or the back of the number. So for example, we have this really large number here that can be represented by 6.9 times 10 to the 25. It's much easier to write that than all of those zeros. Another example here, you see a lot of zeros in front of the 588, can be rewritten as 5.88 times 10 to the negative 11. Now, how do we convert a number to scientific notation? So the first step that you want to do is you want to place the decimal so that the number is in between 1 and 10. So if you look at this number here, where could we put the decimal point so that we satisfy that rule of less than 10, more than 1? Right here. So we get a number of 1.989. Step 2, you want to count how many spaces the decimal point moved. So it moved, if you count, 3, 6, 9, 12, 15, 18. So 18 moves that the decimal point had traveled from the beginning to where it currently, where our number is right here. So step 3, we're going to rewrite the answer, and you get 1.989 times 10 to the number of spaces that the decimal point moved. So this is the scientific notation for this very large number here. Now, you might be wondering, gee, when is that exponent going to be positive or negative? Well, if you move the decimal point to the left, the exponent will be positive. So, for example, we had this problem that we have already done, and we know that that was 1.989 times 10 to the 18th, and the reason why is because you moved the decimal point to the left. If you move the decimal point to the right, the exponent will be negative. So for example, let's go ahead and put this into scientific notation. So remember, the first step is to place the decimal in a way that lets you have a number that is between 1 and 10. So that number will be 5. So the decimal point will be placed after the number 5. Step 2, you want to count how many steps, how many spaces the decimal point moved from its original point to its new position. That number is 6. When we rewrite the answer, we get 5 times 10 to the negative 6. And you'll notice that the negative 6 denotes that you move the decimal point to the right. And up here, you notice that the positive number, the 18, says that you move the decimal point to the left. Now, when you are converting scientific notation back into decimal notation, the longer form, the first thing that you want to do is identify the exponent. So here, you identify the exponent as being positive 18. So step 2, you need to move the decimal point that many spaces to the right. Because it's positive, you move it to the right. So the decimal point is here, and you move it all the way over 18 spaces, and any places that have a hole, you want to fill that with zeros, and so now we have our original answer. For this example, we have 6.7 times 10 to the negative 3, and again, remember, you're going to move the decimal point that many spaces, but because it is negative, you are going to move to the left. So we have identified the exponent, we move the decimal point that many spaces, so we have 6.7, we're going to move it 1, 2, 3, and there's 2 spaces that you're going to fill with the 0, so your answer should be 0.0067. Now, rules for scientific notation. You must, when you're adding or subtracting, you need to make sure that the exponents are the same before you do any calculations. So here is an example, 1 times 10 to the second plus 2.2 times 10 to the 3, the third power. So what you want to do is you need to change one amount. Let's go ahead and change this number here. So in order to make the 10 to the 3 10 to the 2 power, all we need to do is move the decimal point over to the right. And when we move that over to the right, it's going to go down. So if we move it over to the right only one space, we can make the 10 to the 3 10 to the 2. So now we have 1 times 10 to the 2, which is the same, plus we move the decimal point over once, so that's 22 times 10 to the 2. Now we can go ahead and add these, which is 1 plus 22. Oops, and I believe I accidentally subtracted them. So it should be 23. 23 times 10 to the 2. Now we do also need to rewrite that into correct scientific notation, which would be 2.3 times 10 to the 3. Because we moved it to the left, the number gets larger, and we moved it only over once, so that means that our exponent goes up by 1. So again, remember that this was just a mistake and you should have added it, so it should be 23 times 10 to the 2 and 2.3 times 10 to the 3. When multiplying scientific notations, you want to add the exponents. So for example, you have two figures here in scientific notation, 3.7 times 10 to the 5 times 2.1 times 10 to the 8. Notice that the exponents are 5 and 8. So all you need to do is multiply the 3.7 with the 2.1 and then add the exponents and keep it in the scientific notation. So you've got 7.77 times 10 to the 13. Now, one of the things that we need to make sure we do is we keep the significant figures correct. So here we have two significant figures, and here we have two significant figures on the 2.1. So we need to only have two significant figures with the 7.77. So rounding it up, we've got 7.8 times 10 to the 13th. Now, when you are dividing scientific notation, you need to subtract the exponents. So for example, we have this example of 8 times 10 to the 4th over 2 times 10 to the 2nd. So all you need to do is go ahead and divide 8 divided by 2 and then subtract the exponents and keep it in scientific notation. So 4 times 10 to the 2. Pretty easy. So be ready to use this in the next activity. Review this video if you need to, and good job.